Good morning. So we will start with the basics of fiber optic communication. Hope you have come across any glass fiber or an optic fiber or plastic fiber. So we will study about the characteristics of fibers. Okay. So today's discussion we will focus on the basics of fibers, like what is reflection, how light rays will reflect, when is the condition that light rays will refract. Okay, so what are the concepts of total internal reflection? So how total internal reflection takes place inside a fiber? How it happens? We will see some tutorial problems. Okay, so this is what our discussion of topic today. So if you have two different mediums, say you have air medium, the general air medium, and also a core medium. So what is core here is the glass core you use or the plastic core you use, whichever is used for transmission of information through light rays. So if I talk about optics, so optical communication it talks about in the form of light. Okay, your transmission will happen in the form of light. That means your communication happens has to be converted from electrical energy to light energy. So your communication happens through light energy, and in the receiver side, your light energy is again converted back to the original electrical parameter. Right? So this is the basics. So this all we all know all this, right? So now why this communication? Why? Because we have seen number one, because of the bandwidth availability. Very huge bandwidth availability is there with respect to the fiber. Okay. So then number two, very high data rate. Okay. So both are same, almost same. So very high data rate in the sense the speed of communication, right? How fast, how effective the optical communication can be, right? So this is about your optical communication, right? Optical fiber communication. So in the form of fiber, then what is the third one? Third option. Third option will be very less interference. Interference will be very less. Okay. Interference in the sense external interference or any interference due to external noise or due to any okay losses will be very less. Okay, external interferences will be less. Okay, very less losses. Okay, losses are less. So we do have core loss and cladding loss. We'll come to that later. But you don't have any copper loss or iron loss because we are not going to use a copper fiber or a coaxial fiber. We are going to use a copper cable or a coaxial cable. We are going to use only a optical fiber, right? So if your N2 is less than N1, you come back to the basics. So there are two mediums, N2 and N1. So if you have your air as one medium, how the light rays will reflect? Okay, what is this total internal reflection concept? Okay, total internal reflection happens inside the core. Okay, the core of the fiber. Core நீங்க சொல்றது what we say is the whatever you take glass, plastic, okay, plastic core or a glass core. So within that how it happens. Okay, so the refractive index is very important. Okay, the index of refraction. Okay, index of refraction. So that is Snell's law is given by N2 by N1. Okay, so what is that ratio? That N2 by N1 ratio will depend on how far you use your medium. How far you use the medium? Say for example, you know light travels very faster in space. So whether light travels in water, whether light travels in air, how light travels in vacuum space. So there are different concepts. No, accordingly you will have this total internal reflection. Okay, so we will come to this now. So we'll just see what is this concept now. We'll draw a simple diagram to explain you. Okay, see this is your core of your fiber. This is the optical core. So you have light rays entering here. Again it will reflect back here. Again it will reflect back. Okay. So this is what it happens. So here happens. Again it will reflect. So this is your core part. So this part is your core. Okay, the actual core. So So if I draw like this, you just take it literally, don't take it this much higher. So the spacing will be very less. So if you take or if you talk about nanometer or micrometer thickness, the core will be very less. Okay. The cladding will be the outer part of your core. So we have seen this is the cladding. So when light enters your cladding space, which is your say some form of insulation sheet, okay. Whenever light travels here, it will travel inside the core in a zigzag manner. Why? Because that is internal reflection. Internal reflection means within the fiber, within the border walls, or within the dimension of the fiber. Okay, light will bombard here and it will reflect back. Again, it will fall in the same region. Okay, so it will follow a zigzag path. So this will be your, so this will be a part of travel inside your. Okay, so this will be a part of travel inside your fiber core of your optic fiber. Right. So, for example, say this is your N2 or this is N1. That means core and clad will have a different refractive index. Then only you will have your uh, propagation of light proper inside the fiber. Okay, it should have a proper light propagation or wave propagation only when the refractive index are different. The refractive index is same, there no reflection will take place. Everything will be reflected back. Everything will be refracted. So there will be no reflection. Okay, that is your total internal reflection concept. Now we will come back to yeah. We will take another example. So we are clear with this. How light travels inside a medium. Okay. So transmission of light within a fiber with respect to total internal reflection. So if your incidence angle is less than your critical angle. So what is critical angle? The angle which is needed for your reflection to take place. That is your critical angle. Incident angle is what is the input. The input at which your the incident angle is your input angle. That is at which your light is incident on the fiber. That is your incident angle. If your incident angle is less than the critical angle, then what happens? So light will be totally reflected. So then light will be totally reflected. So this is in the case of zero loss, but in practical case you have losses. So total internal reflected without attenuation. So very important this term. So each and every term is important. Without attenuation, without any signal loss or without any signal power reduction. Okay, without any signal loss, it will be reflected. That means what? That the entire signal strength will be transmitted from the input side to the output side, or from the source to the destination, or from one end to the other end to the length of the fiber. Okay, that is your concept. So for core cladding interface, we have seen some simple. Oh, see whether the board is clear, screen is clear. Students, whether the screen is clear, so kindly respond.
Yes,
Is the
sir.
screen clear?
Yes, sir.
Okay. Is my voice audible?
Yes, sir.
Yes, sir.
Okay, fine. Thank you.
Yes, sir.
Okay, okay. So we'll see a few concepts now. Okay. With respect to the core and cladding concept, right? So the refractive index of core will be equal to N1 equal to 1.54. Say for example, you take a glass fiber, refractive index is 1.5, or the index of refraction. Okay, how much ever refraction has taken place, that is 1.54. Okay, then your cladding interface is N2 is equal to 1.5. Okay, the cladding interface is 1.5. So these are the data given to you, right? So now calculate what is this numerical aperture. Okay, what is numerical aperture? Okay, you have to calculate what is the numerical aperture and also the maximum acceptance angle. Okay, you have to calculate the maximum acceptance angle. Okay, right? So how will you do this? So you are asked to calculate what is numerical aperture. So you should know what is numerical aperture. The aperture is nothing but you can simply say the light gathering capability of a fiber. Okay, how much light it can withstand, how much light it can travel, it can propagate. Okay, whether it can propagate in a single mode or multi mode or double mode. Okay, that will talk about the light gathering capability. So here you come across what is called TE mode, TM mode. So you have come across different propagation of light in your transverse electric mode or transverse magnetic mode. So it will be a combination of both. So we have also hybrid mode of propagation. Okay, so we'll come to that later. So simply, if you want to calculate the numerical aperture, so you can take it as NA equal to root of, you can say N1 square minus N2 square. Simple. Okay, so this will give you the aperture. Aperture, you can take it as N1 square minus N2 square, not in the reverse. Because always N1 will be greater than N2. Okay, always remember the core refractive index will be greater than the cladding refractive index. Or you can say it as core index will be greater than clad. Clad means you put D. Clad index will be lesser compared to the core index. Then only reflection takes place. Because when your outer medium is lesser with the less index, then your inner medium will can propagate. Otherwise, light will be okay. Light will scatter. That should not happen. Okay, there is a small issue. Fine. So this is your core refracting index F1. This is your class refracting index F2. You always remember in whatever problem or question it's asked, whether in any competitive exam or whatever or wherever, your core index should be always greater than compared to your class index. Okay, wow. So if you calculate, this is the formula to calculate your refractive index. So using this formula, calculate, you will get a value of numerical aperture. Okay. So now then you have to calculate the maximum acceptance angle. So you have a relation between your maximum acceptance angle and your numerical aperture. Fine. So hope you have calculated. So time frame was given to you how to calculate your refractive index, sorry, numerical aperture. So you have, hope you have calculated the numerical aperture. Okay, what it is L1 square minus L2 square, the whole power 1 by 2. Or simply you can say L1 square minus L2 square, the whole power 1 by 2. This is your numerical aperture. Okay, or simply the light gathering capability of your fiber. Okay, it comes to around, so how many of you have calculated? Comes to around 0.3. Okay, so just check it. It comes to around aperture is 0.3. Okay, so it is 0.3. So now you have to calculate theta. Okay, so how will you calculate theta? Theta you can calculate it as sine of, okay, sine theta will be equal to aperture. Aperture is nothing but sine theta. Okay, the aperture, or simply we call it as aperture. Aperture means it is the numerical aperture of the fiber. So numerical aperture of the fiber is equal to sine theta. So if you want to find theta, it is simply sine inverse of your aperture. Or if you know theta, you can calculate numerical aperture as sine of theta. Anyway, if you are given aperture, you can calculate maximum acceptance angle of the fiber, or if the acceptance angle is known, you can calculate the aperture. Okay, so if you just calculate, it will be sine inverse of. So what is the answer? So it is sine inverse of 0.34. So this is your theta. So your theta will be 20.4. Okay, 20.4 degrees. So next we have another okay, interesting question. So if you solve few problems, you will be able to handle okay questions in your competitive exam. It is always better to solve problems and then study the concept. So it will be easily understandable. Okay. So the angle of incidence, okay, for a step index fiber is 11 degrees. Okay, incident angle is 11 degrees. Okay, okay, the refractive index of your core will be equal to 1.5. Okay, refractive index is 1.5. Find the refractive index of the cladding. Clad for the refractive index you have to find. Core is given. Okay, so this is your question. How to solve? So you can solve it by using a simple uh, okay concept like your incident angle. Okay, your incident angle. Okay, plus your critical angle. Okay, should be equal to what should be the incident angle plus critical angle? So it should be equal to some complementary angle 90 degrees. So it should be 90 degrees. See, it is a straight line. Your incident angle and your refracted angle both should be equal to 90 degrees. So it should be 90 degrees. Okay. So then only internal reflection happens inside the fiber. So you have to calculate what is your critical angle. Critical angle is 90 degrees minus the incident angle, which is 7 degrees. So you get 90 minus 80, 79. So critical angle is 79 degrees from the given data. Okay, so critical angle is 79 degrees. So this critical angle will be equal to, so you can relate this critical angle with respect to the refractive index of the core and the clad. So okay, so this will be equal to sine inverse of clad index by core index. Simple. So you have your critical angle 79 degrees. So it will be sine inverse of N2. You don't know what is N2. So N2 by clad index. Sorry, core index is 1.5. So simply you can calculate. Okay, so what you will get? N2 by 1.5 is sine 79. You will get this type. Okay. So both sides you put sine means sine 79 will be equal to N2 by N1. Okay. So you will get N2 as 1.5 times sine of 79 degrees. So you get you should get N2 less than 1.5. That is your okay hint. N2 should be less than 1.5. You are getting it as 0.9. You are getting it 0.9. Okay. So now you come to the concept. Your critical angle and your incident angle should be equal to 90 degrees always. This is a rule. So in your optics, this is a rule that incident angle and critical angle should be equal to 90 degrees. It cannot be 180. It should be 90. Then only reflection takes place. Either reflection or refraction. Okay. So if it is straight line means just your ray will pass. You cannot propagate through the fiber. Optical medium will inside the optical medium if you want to transmit or propagate. Okay, so it should be equal to 90 degrees. Okay, which should be equal to 90 degrees. The sum of critical angle and your incident angle. Incident angle is the input what you give, what input what you take. Okay, critical angle is what you calculate. Okay, both should be equal to 90 degrees. So if one value is given, you can calculate the other value and you can find out the result. Can be equated to this and this thing. Okay, that means if your medium of propagation is different. Okay, if it is have a different refractive index, that is, if the core index having more index compared to the clad index, then only the propagation of light travels take place inside the fiber. Then you can calculate these values. Okay, so this is just an example. So we have not incorporated the losses here. So if you bring losses into the picture, the critical angle might differ. Okay, so like this, if you start doing simple problems, you will understand. Sorry, the answer is 1.4. take it down. Result is N2 value will be equal to sine of 79 multiplied by 1.5. So you get 1.4, 1.47. Anyway, less than 1.5 you will get. So N2 is 1.4. Whatever I wrote, 0.9 is for sine of 79 degrees. Sine 79 will be 0.9. Okay, 0.98 is this 1.5 times 0.98. Okay, that will be 1.47. Because if it is 100% means you will get 1.5. If it is 98% is 1.5, it is 1.47. Right? So your N2 will be 1.47. So you have followed the result. So if you solve simple problems, it will be helpful for your if you sit for any examinations, right? So acceptance angle and the angle of numerical aperture should be taken for okay, as a relative parameter, right? Okay, next we will talk about we hope this is clear. So what all we have studied, we have just dealt with what is total internal reflection. Okay, so how core index and clad index will be compared. Okay, how it can be compared with respect to an optical fiber. Okay, so what is core? What is a clad? Okay, so above the clad also. So see, for example, if you have this as a core, then you have the outer thing as a clad. So this will be the core of the fiber. This will be the clad. Outer thing you will have a insulation sheet also. Okay, insulation sheet. So this only here inside this your light will travel, but it should have proper protection from any external disturbances or any interferences. Okay, so that your clad will take care of your core and also the outer insulation sheet. Okay, that's what we have discussed till now. Then also we have discussed about what is numerical aperture. Okay, numerical aperture is equal to sin theta. Okay, what is this theta? This theta is an acceptance angle, maximum acceptance angle. Okay, aperture is nothing but the light propagation, light capability, light gathering capability. Okay, if you are somebody asks you can say it is simply the light gathering capability. How much ever light it can travel or it can withstand. That is the aperture. Simply we say aperture or we just numerical aperture with respect to optic. Okay, or theta will be equal to sin inverse of, or you can say aperture is given means sorry n1 n2 is given means root of n1 square minus n2 square, or simply root of okay aperture will be equal to root of fourth index square minus plan index square. Okay, so don't forget these things too. Okay. So we come to the next topic. So we will have this. What are the different modes of propagation? Okay, we have single mode propagation, we have multi-mode propagation, and what are the different types of okay wave propagation inside the fiber. First one we have depth index fiber. Second we have graded index fiber. So we will see about these types of graded index fiber, step index fiber, how to define the mode of propagation inside a fiber as step index, graded index. When you call it as step index, graded index, what is a single mode propagation, multi mode propagation? Okay, what is transverse electric mode, what is hybrid mode of propagation? All that we will discuss in the next subsequent class. Okay. Students, I need feedback. How was the class? One by anybody can open up and talk. See, don't go away from the class. Be inside. I will take your attendance and then we can discuss. Yes. Yes. Somebody. Kiran. Nived.
Present, sir.
Present சார்லாம் கேட்கல கிளாஸ் கவனிச்சியா என்ன டாபிக் எடுத்தேன் இன்னைக்கு சொல்லு
Refractive of
see whether it was interactive